Hello Year 4, it's Miss Lewis here and this is Thursday's maths lesson. So let's start with Give Me 5. We've got a division focus today. Set yourself a 5-minute timer, pause the video and off you go. Okay then, let's start. So 55 divided by 5. If you know your 5 times table, you should be able to know this answer. And we know that a lot of things, when it's a double number, they're usually in the 11 times table. So there we go, 55 divided by 5 is 11. Next, share 42 into 7 groups. Okay, so you could have drawn out your arrays, you could have drawn out 42 dots and made sure that there are 7 groups, and you would have got 6 dots in each group. We know that the number sentence there is 42 divided by 7, and we get 6. Okay, next question, we are grouping now. Group 54 into 9s, which means we want 9 in each group. Okay, and work out how many groups there are. Also, if we know our 9 times table, we'll be able to work this out. So 54 divided by 9, I know that that is 6 again. Next one we come to then, it's a 3-digit number, 486 divided by 2. I am going to draw out our bus stop for this one. So I'm going to put 486 into the bus stop and the 2 on the outside. Now I need to ask myself how many 2's can fit into 4. 2, 4, that's 2 2's. How many 2's can fit into 8? I'm going to count up in 2's till I get to 8. So 2, 4, 6, 8. That's 4 lots of 2. And then how many 2's can fit into 6? Again, I'm going to count up in 2's until I get to 6. 2, 4, 6. That's 3. So my answer then is going to be 243. You could have done that one in your head by dividing the 1s, dividing the 10s and dividing the 100s, because they are all numbers that are very easily divisible by 2. Okay, and our last question here then, what numbers can fit perfectly into 24? Okay, another way of saying this is what are the factors of 24? So we're looking for all the numbers that times together with another number to make 24, and there's quite a long list of them. So 1 and 24, you can have 1 times 24, it's 24. 3 and 8, so 3 times 8 is 24. 4 and 6, 4 times 6 is 24. And then 2 and 12 is 24. So all of these numbers fit perfectly into 24. Well done if you got any of those right. Even if it was just a few of them, you've still done really well. Let's move on to our in focus problem for today then. Okay, we've got a picture and some writing here. A glass of water was left in a freezer. Here is our picture. Glass of water was left in a freezer. Its temperature was taken every 10 minutes. Okay, so you can see we've got a thermometer in that water, and every 10 minutes someone came along and took the temperature. So we can see here the thermometer. So at the start of the experiment, it's very blurry, but I think that is 25 degrees. Then after 10 minutes it had gone down a bit. After 20 minutes, and I'm pretty sure that is I can't quite read that. Maybe you'll be able to read it a little bit better. But we can see that the temperature is going down and down and down. And after 60 minutes, it seems to be all the way down to the bottom to 0. And it looks like it stayed that way for a while. So, our question here, can we draw a line graph for this data? How do you know? And how would you organise this information before drawing the graph? So have a think to yourself, pause the video if you need to. What do we think of these questions? Can we draw a line graph? How will we organise the information? So yesterday we learned that line graphs were helpful when we were measuring something over time. Okay, so we're measuring the quantity of something as it changes over time, and usually it goes up or down or stays the same. Okay, and we can see here that time is passing. So the start of the experiment, 10 minutes, 20 minutes, 30 minutes, 40 minutes, and so on. And we're measuring something against that time. So yes, a line graph would be good. Next question, how would you organise the information before drawing the graph? Always before drawing a graph, it's a good idea to draw out a table so we can see the data a little bit clearer. Okay, and it will certainly help me trying to read these thermometers. Let's have a look then. So let's put this information in a line graph. What information would you put in the columns? Well, I think along the bottom I would have my time, and along the side, so along the bottom, this axis, I would have time, T for time, and along this axis here I would have the temperature. Both start with T, TE for temperature. Okay. What time would you assign to the start of the experiment and why? Okay, so a start of experiment, 10 minutes, 20 minutes, 30 minutes. Have a think. Yep, it's 0. 0 minutes have passed. Okay. And that's how we are going to label the axes with the temperature and the time. Let's see how they've done it then. Okay, perfect. So the first step, as we said before, is to complete the table. So they have very helpfully drawn out the table for us here. So after 0 minutes, so at the start, 0 minutes, the temperature was 25 degrees. After 10 minutes, 15 degrees. After 20 minutes, it was 5 degrees. After 30 minutes, it was 3 degrees. And then from 40 minutes and onwards, it stayed at 0 degrees. Okay, so first step always is to draw out a table. Second step, we need to put the information from the table into a line graph. Okay, so we have decided to go up in steps of 5s. Okay, so it goes up in steps of 5s along the temperature axis. Remember, they've labelled their axis with the units as well, so we're in degrees Celsius, and they've got their title of the graph as well, which is the temperature of water. Okay, so they've chosen to go up in 5s. Even though there is a 3 here, we can still fit it into our graph, it still works. And we've gone up in 10s in the minutes because those are the increments, what they're called, that we have here. Okay, so they've plotted it, so they've done 0, it's 25, after 10 minutes it was 15, after 20 minutes it was 5, after 30 minutes they've used what they do know, it's not on a line, but they know that sort of halfway between 5 and 0 is 3, and then at 40 minutes it was at 0, so it's on the line. And then only after they put their points in, they have joined them together with a ruler. Okay, we've got questions here. So what trends are clear from the data? So did the temperature increase, decrease, or remain the same? That's right, we know that the line is going down, and when something is going down, it is decreasing. Okay? Is it as you would expect? So when you put water in a freezer, would you expect the temperature to go down to 0? I think you would. Here we have a question. What was the approximate temperature of the water after 15 minutes? Approximate means a good guess. Okay, so if I want to find out about, for 15 minutes, I need to go between 10 and 20 because I know that's 15. And then I will go up to the line. There we go, and go along. So I could safely say, as an approximation, that after 15 minutes, the water would have been about 10 degrees. Okay, and after how many minutes was the temperature at 20 degrees? Okay, so now I need to find 20 degrees, go along, make a little dot for myself, and then go down. I'd use a ruler. Here we go. Halfway between 0 and 10, I know that's about 5 minutes. Okay, so we put the information in a graph, and now we are using the graph to help us answer some questions. Okay, on to our guided practice then. So here I have included the table and the graph here to help us so we're not flicking back constantly. So, first question, what was the temperature of the water in the glass at the start of the experiment? Okay, I'll do this one with you to start with. At the start of the experiment, 0 minutes. So we know we just go up along this line and find where the water started at 25 degrees Celsius. Okay, that's how we are interpreting the data here. So the rest of the questions, have a go at them on your own, pause the video and come back for the answers. Okay, let's go through these questions then. So, question 2, by how much did the temperature drop after 20 minutes? Okay, so we need to see where we were at the start and where we are now. So we started at 25 degrees, and after 20 minutes, if I look at my graph, I go to 20, I go up and along, I get to 5 degrees. Okay, so I need to find the difference between these two. 25 take away 5 is 20. So after the first 20 minutes, the temperature dropped by 20 degrees. Okay, you could also do that by going down from the 25, okay, until you reach the 5. Okay, by how much did the temperature drop in the next 20 minutes? Okay, the next 20 minutes. So that's going to be from 20 minutes to 40 minutes. It's the next 20-minute time period. So we go from 5 down to 0. Okay, 5 down to 0. So finding the difference between those, 5 take away 0, we know is 5. Okay, so it dropped by 5 degrees. Okay, question 3. What do you notice about the temperature after 40 minutes? Okay, what do you notice about the temperature after 40 minutes? What happens then? Does our line move? No, it stays the same. Okay, so the line stays the same, which means the temperature stays the same. So I'm going to try and write in stays. I'm going to write stays same. You will have written in something a lot better than I have. Stays same. There we go. Remember, we've got a very helpful speech bubble here that says temperature and time are quantities that can be expressed in fractions or decimals. Okay, so we know that we could use decimals to describe our temperature or our time. So question 4, can you estimate, that means to have a good guess, the temperature of the water in the glass after 25 minutes without having measured it? I think we can. So we know that 25 minutes will be halfway between 20 minutes and 30 minutes, so about here. So we can go up then to about here, where the line is. I think that using our graph ends up about here, which will be about 4 degrees. So we haven't measured it after 25 minutes, but we can estimate by using our graph, by using this line that has been drawn for us, that it would be about 4 degrees. Okay, so well done on your guided practice then. Let's go on to our worksheet. Okay, here it is. We've got 3 pages in our workbooks today. So we are going to be using this table. So you're going to take this data here and pop it into the table, which means you're going to really need to read through these these beakers, you're going to have to see very carefully and pop in the data, which might be a little bit tricky for me because it's quite blurry on my screen. So you pop it in the table, then you're going to use that table to draw yourself a line graph and then answer a few questions about it. And then we've got another beaker of water situation that's left to evaporate and a different graph, and then we're going to compare them. Okay, so have a go in your workbook. It is worksheet 4 and it is page 150. Okay, have a go, pause the video and then come back for the answers. Okay, then you should have completed your worksheet now. Don't cheat and look at the answers before you've finished. Okay then, so our first question was to complete the table to show the amount of water in the beaker after every hour. So all we needed to do was carefully read these beakers and pop the values in. So it started out at 100 millilitres. We put that in. After 1 hour, it had gone down to 90. Put that in. Then it had gone down to 80 at 2 hours. At 3 hours, it was on 65. At 4 hours, it was on 50 millilitres, and then after 5 hours, it had gone down to 30 millilitres. Okay, so well done. That's another skill that we're using here, being able to read measurements like this. Okay, so that's our table. Next, we use that table to draw a line graph. Okay, so after no minutes, it was at 100. Sorry, not minutes, no hours. After 1 hour, gone to 90. 2 hours, 80. Remember, we're using the information in the table to help us. So after 3 hours, it's at 65. 4 hours, it was at 50, and after 5 hours the value was 30 millilitres. And luckily we have this graph all drawn out for us, already labelled, so we've got our title and we've got the labels on our axes, amount of water and time, and hopefully it had the scale as well. Okay, so questions to start us off. How much water was in the beaker at first? So at first means after no time has passed, so we use this, we go up our line, we get to 100, okay, 100 millilitres. How much water was lost after 5 hours? And this is the key word here, lost. It's not saying how much water was in the beaker after 5 hours, it's saying how much water was lost. So how much had it gone down by? Okay, so to do this, we need to know how much we started with. We started with 100 millilitres. And after 5 hours, we had gone down to 30 millilitres. Okay, so I'm using this 5, I'm going up and along, and I get all the way over to 30 millilitres. So we're going to find this difference. 100 take away 30. So knowing my number bonds, I know that that is 70, and this is the answer we've got here. Okay, so after 5 hours, we had lost 70 millilitres. You could also have done that by using this. So 10, 20, 30, 40, 50, 60, 70. Okay. After how many hours did the beaker lose half the original amount of water? So to do this, we need to know what half of the original amount is. So we know that 100 was our original amount. Okay. And I know that half of 100 is 50. So now I need to find out what time did it show 50 millilitres of water. So I need to go to the amount of water part of my graph. I need to find 50 millilitres. I need to go along that line very carefully. And I get here to where it intersects and go down. And that's 4 hours. Okay. Question 3 then. Another beaker of water was left to evaporate for 5 hours. The amount of water in the beaker was also recorded hourly. And this is the line graph for this different beaker of water. So, first question then, how much water was left in the beaker after 5 hours? So I need to use my time axis. I need to find 5 hours, go up to where the line intersects, go along, and I get to 10 millilitres of water. Super. How much water was lost after 5 hours? Okay, similar to the question we had before. So we started with 100. At 5 hours, we only had 10, so we do 100 minus 10 because we're finding that difference, and we get 90 millilitres. Again, we could also have done that by counting down from this period of time here. So from the starting to where we get to after 5 hours. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So we're down to 10 millilitres after 5 hours. Okay, compare the water loss from this beaker with that from the beaker in question 2. Which beaker lost more water over 5 hours? Okay, so let's go and look over here. How much water was lost after 5 hours in this question? It was 70 millilitres. How much water was lost after 5 hours in this graph? It was 90 millilitres. So we know that 90 is more than 70, so the second beaker lost more water after 5 hours. Okay, well done. If you got any of those questions right, it's a bit of a different skill, but you have done really, really well. If you think that you have challenged yourself enough today, that's it, you can finish your math lesson. If you want even more of a challenge, I have got a challenge question for you. Okay, here's our challenge question. Tommy created a line graph to show the number of dogs walking in the park one afternoon. Tommy says, at 1:30, there are 1.5 dogs in the park. Why is Tommy incorrect? And what would be a better way of presenting this data? Pause the video now to work out your answer. Okay, so here is the answer to our challenge. So, first question, why is Tommy incorrect? He says that at 1:30 there are 1.5 dogs in the park. Well, you can't have 1.5 dogs. You've either got 1 dog or 2 dogs. You're not going to have half a dog walking in the park. That's not how it works. You've either got 1 dog or 2 dogs. So measuring in things like dogs are things that you've got to measure in whole numbers for. Okay? So he's incorrect because you can't have 1.5 dogs. Next question, what would be a better way of presenting this data? Okay, the answer here says a better way of presenting this data would be using a bar chart, pictogram, or table, because the data is discrete. That means it stands alone. Okay, it means it can't be measured in anything other than whole numbers. So let's have a go at drawing a bar chart for this then. It'll be a very messy one, so I don't have tools like a ruler. Okay, so 1 p.m, 2 p.m, 3 p.m, 4 p.m, we can still use the same scale. And then we've got a number of dogs over here. 1 dog, 2 dog, 3 dogs, 4 dogs, 5 dogs. Okay, so at 1 o'clock there was 1 dog. Just using the information I can see here. At 2 o'clock there were 2 dogs. At 3 o'clock there were 5 dogs. Nope, wiggly bar there. And at 4 o'clock there were 2 dogs. Okay, this is a much better way of presenting this data, because with the line graph we can make estimates. That's what a line graph is useful for. Okay, But here we can't estimate the amount of dogs at 130 because that is not a sensible amount of dogs to have. So a bar graph is best for using this amount of this type of data that can only go up in whole numbers. Super work if you got that, well done. If you want even more of a challenge, why not find out some answers to questions around your home. Maybe go around your house and ask everyone's favourite chocolate bar or favourite subject and see if you can make graphs, line graphs, or bar graphs for favourite subjects. Or maybe you could do the experiment if you want to. You could leave a glass of water in the freezer and measure it and make a line graph from the data that you find. If you want to challenge yourself, you don't have to. That's if you want even more of a challenge. Well done, everybody. Have a lovely rest of your day and half term as well.